All right, so properties of exponents, we're going to look at a little deeper than an intro to algebra class and like an algebra class, right? So some basic rules: zero exponent, anything to the 0 power is 1. All right, so I'm going to go quickly through the rules, but feel free to go back and review the rules on your own. Anything to the 0 power, a to the 0, 1. Negative exponents. If you have a negative exponent, 4 to the negative second can be rewritten as 1 over 4 squared. Or if you have 1 over 4 to the negative third, that will be rewritten as 4 to the third. A to the negative n power is 1 over a to the negative n. Or if you have 1 over x to the negative fifth power, then this is going to just be x to the fifth power as a positive exponent. So anything that's positive should be in its opposite numerator or denominator. If you have a to the negative third, b to the negative fifth, this can be rewritten as b to the fifth as a positive exponent over a to the third as a positive exponent. So they're pretty much just swapping location, right? That should be down below. It's in the numerator as a negative. It should go in the denominator as a positive. This one's in the denominator as a negative. It should go in the numerator as a positive exponent. All right. Product rules. 4 to the third, 4 to the 6 times 4 to the third. They both have the same base. Different exponents. Just add the exponents. Keep your base and add your exponents. Right? It's not 4 times 4 is 16 and 6 plus 3 is 9. It's 4 to the 6th power, 4 to the 3rd power. Keep the 4 and just add your exponents. All right, same thing here. So I'm going to give you another example. If you have x to the 5th times x to the 3rd, all right, keep your x and add your exponents. You get x to the 8th. All right, I'm going to give you another example. What if you had x to the negative 5th times x squared? Keep your base. Negative 5 plus 2 is x to the negative 3, and then rewrite this as 1 over x to the 3rd power. All right, so add them first, and if it's a negative exponent, just make sure you rewrite it as a positive exponent. All right, the goal here is not to have any negative exponents. Quotients. All right, so if you're multiplying, you add the exponents. If you're dividing, you're subtracting the exponents. All right, so same basis: 6 minus 3, 4 to the 6 minus 3 power, and you have 4 to the 3rd. Let me give you an example here. If you have x to the 6th over x squared, keep your base x and subtract your exponents to get x to the 4th. What if you had x to the 7th over x to the 12th? Okay, you would keep your base, 7 minus 12, and you get your x to the negative 5 or negative 5th power, which becomes 1 over x to the 5th. Again, rewriting my exponents as positive exponents. And lastly, your product rule, 4 to the 6th all to the 3rd power. Keep your base and just multiply your 6 times 3, and this is your power rule. So if you have a to the 3rd to the 4th power, this just becomes a to the 12th. Okay. Or let me give you another one with negative exponents. If you had a to the 3rd to the negative 2nd power, then this becomes a to the negative 6th, which can be rewritten as 1 over a to the 6th. Next property, power over product property. All right, so you're multiplying 3 times 2, so different bases. This is the same thing as saying 3 to the 5th times 2 to the 5th. Ideally, I wouldn't do that. I would do 3 times 2 is 6, and then 6 to the 5th power. That's what I would do, or put it in the calculator, or figure out. I wouldn't do this separately, but that is one of the properties. This mostly works into, if you have an example, let's say a to the 2nd times b to the 3rd, all raised to the 4th power. You want to apply this power to both of these. A squared to the 4th power is a to the 8th. B to the 3rd to the 4th power is b to the 12th. So make sure you're giving that power to both these numbers inside. Notice this is not a squared plus b to the 3rd and giving the power to both of these. Okay, the same rules do not apply with addition or subtraction, right? This is just for multiplication that you could do that. All right, the addition and subtraction, we'll get there in the next couple sections. All right, and then the product rule, so same thing here. If you're dividing, you give it to both. So let's say I have a to the 5th over b squared, all raised to the 3rd power. I'm giving my power to the numerator, which is going to be a to the 15th, over, I'm giving my power to my denominator, which will be b to the 6th. All right, so we got 5a squared, the quantity 5a squared, b cubed, all squared, and a to the negative 3rd, b to the 15th in my denominator. All All right, so something I want to point out here is notice just the numerator is squared, or just the numerator is in parentheses, and then you have a square. So this square only applies to the numerator, not the denominator. If I had rewritten this like this, then that square would apply to everything, right? If it was rewritten that way. But the squared here is just rewritten, it's just with the numerator. All right, so I'm only going to square the numerator. All right, so we're going to go about these problems different ways. There is no right or wrong way to which step you should do first. It's just mostly preference. Sometimes some steps can make things a little easier. Okay, so you're going to have to play with these a little bit. All right, so I'm just going to square the numerator first. Okay, I can't simplify a squared and a to the negative 3 here. I can't simplify these because one of these is being squared and the other one's not. So let me take care of the square first. So I'm going to square my 5 and get 25. I'm going to square my a squared and get a to the 4th. I'm going to square my b cubed and get b to the 6th. All right, and then I'm just going to rewrite my denominator as a to the negative 3rd and b to the 15th. Okay. Step in simplifying this. All right, and now I want to simplify this again. I have 25 over 1, so that's just really 25. All right, my a to the 4th and a to the negative 3rd. I'm going to keep my base, a, and I have 4 minus negative 3. And then my b's, I have b to the 6th minus 15. All right, so I'm subtracting, keeping my base and subtracting. So if I simplify this, I have 25. 4 minus negative 3 is a to the 7th. And 6 minus 15 is b to the negative 9th. Almost done, not completely simplified because I have b to the negative 9th. So this should be 25, a to the 7th, and my b to the 9th should be my denominator as a positive 9. All right, this is one way to look at this. I have also looked at this a slightly different way. And again, whatever works for you and whatever makes this easier, okay? So I'm going to re-look at this again one more time. And just to look at this. So I have 25, a to the 4th, b to the 6th, over 1. So 25 and 1, I know my 25 is going to stay in my numerator. Here I have a to the 4th and a to the 3rd, which a to the 4th is positive, so that stays positive, so that stays exactly where it is. A to the 3rd is negative, so I'm going to rewrite that as a positive right next to it. And then b to the 6th is positive, that stays where it is, and b to the 15th is positive, that stays where it is. And if I simplify this, then I have 25, a to the 4th times a to the 3rd is just a to the 7th. And then I have b to the 6th and b to the 15th. Where do I have more b's? In my numerator or my denominator? So I have more in my denominator, so my b is going to stay in my denominator. And why does it stay in my denominator? Because I have how many more? 9. And I could just stop it there as well. All right, so you could go through the steps here of the subtraction and then moving your variables where in an appropriate location. Or you could move your variables now. When I rewrite this, sometimes I skip the step here and I don't write the a to the negative 3rd separately. I would just write it here, a to 3rd, and then just look at these together. And I say, okay, a to the 3rd, a to the 4th is a to the 7th to save a step of writing. As you do more and more of these, I think these become more and more mental, and you can do these a little bit easier and faster. In the first couple examples that you do, or homework problems, I would just keep writing down as much as you can, and then go from there. Okay, and forgot to write my a there. All right, so 25, a to the 7th, b to the 9th. Next example. 2x, y to the negative 1 over the quantity 2x, y to the negative 4th, x to the 4th squared. All right, so again, I'm not squaring the entire fraction. I'm only squaring the denominator. All right, so I could go right now and square each one of these, the 2, the x, the y to the negative 4th, and the x to the 4th. However, before I square all those, I'm going to ask myself if there's anything in those parentheses I can simplify first. Can I put anything together? Because if I have 7 terms there in my denominator and I can simplify them down to 3, then I only have to worry about squaring 3 terms rather than 7 terms. Right? Because squaring 7 terms, you might forget one, or there's more room for error there. So my denominator is 2x, y to the negative 1. Nothing happens there. I'm going to clean up my numerator. My denominator, I see I have x to the 1st and I have x to the 4th. So this could be rewritten as x to the 5th, y to the negative 4th. And then I'm going to apply my square. So 2 squared, 4. X to the 5th squared, x to the 10th. Y to the negative 4th squared, y to the negative 8. So I first cleaned up my denominator, simplified these 4 terms down to 3 terms, and then squared. Okay. And from here, now I can say, okay, let me simplify this. And again, you go take whatever direction you want. I'll do both on this one. So 2 over 4 is 1/2. I have x to the 1st minus 10, because I have x to the 1st and x to the 10th, so it's 1 minus 10. And then I have y to the negative 1st minus negative 8, all on one line. So this is going to give me 1/2 x to the negative 9, y to the 7th, which can be rewritten as 1 over 2, x to the negative 9th is negative, so that should be in my denominator as x to the 9th, and y to the 7th as my final answer. All right, that's one way to approach it. So we got 2 over 2x to the 1st, y to the negative 1st. Okay, so you can speed this up as you get faster with these, all right? So 2 and 4 is 1 and 2. I have x to the 1st in my numerator, x to the 10th in my denominator. Where do I have more? Denominator. So my x stays there. How many more? 9. Y to the negative 8th really means I have y to the 8th up here. Y to the negative 1st really means I have y to the 1st here. 8 and 1, where do I have more? My numerator. How many more? 7, and stop there. The whole thing is being raised to the negative 1st power. All right. So I can go ahead and distribute this negative 1 to all these numbers. Do I want to? Me personally, no. I said I'm going to clean up as much as I can inside my parentheses and then apply the negative 1 power. All right. So I have m to the negative 3rd, m to the negative 3rd. Cool. Those two could go together. I have a 2 up here and nothing else. N to the 0, I see that, and that goes away because that's 1. So 1 times anything, that's gone. My denominator, I have m, n to the negative 2. I don't have any numbers. Okay, cool. So let me take my first step, and I'm just going to rewrite this as 2 m to the negative 6 over m n to the negative 2 power, all raised to the negative 1. Okay, so I definitely cleaned it up. I could clean it up more if I wanted to. All right, so if I were to clean this up even more, this m to the negative 6 should come down here as m to the positive 6. So my 2 is going to stay. And if I bring this positive m to the negative 6 down here as m to the positive 6, then I get m to the 6th and m to the 1st, which is m to the 7th. And then this negative 2 should come up in my denominator as a positive 2. And is there anything that simplifies with? And then I go put that back. So a very common mistake is when you're doing this, don't forget to rewrite that negative 1 to everything. All right. So now let's apply that negative 1 to everything. So 2 to the negative 1st, m to the negative 2nd, and m to the negative 7th, which then just really means all my exponents are negative. So everything in my numerator should go down below with a positive exponent, and everything in my denominator should go up above with a positive exponent. So as you get faster and you see something like this, then you could skip this step here and say, well, if the whole thing's to the negative 1st power, then just flip-flop my numerators and my denominators. My numerator is now my denominator is now my numerator. And you could have done that step anywhere. Right? You could have done that step here in the first step. Me, like again, it's all preference. I like to clean it up as much as I can and then apply the exponents. All right, so I have this whole quantity to the 4th power. Again, I'm not going to apply this 4th power to everything. I'm going to clean up everything I can. So coefficients, I have 2, 2, and 2. Okay, so that's going to simplify to 8. I have 8 to the 0. Cool, that goes away. I have any more a's? Yep, I have 8 to the 4th and a to the negative 1. If I add a to the 4th and a to the negative 1, I get a to the 3rd. And then lastly, I have b. And my b, I have b to the 3rd, b to the first and b to the 0. Well, that goes away. So b to the third and b to the first is b to the fourth. Close it, all over, and that's to the fourth power, all over a to the third, b to the negative third. Now, looking at all that, that looked very messy, but then simplify it, and now you just have three numbers, 8a cubed, b to the fourth, and that's pretty much it. Yes? Alright, so now let's simplify what we can. So before I start simplifying, can I simplify a to the third and a to the third right now? The answer is no. Why not? I need to first take care of the exponent, right? First distribute that fourth power to all those, and then I could simplify the a to the third to a to the third. If this whole thing was in parentheses, and I had a to the third, and the fourth power out here, I could simplify it and then go. But since only the numerator is in parentheses, I am not able to do that, right? So I have 8 to the fourth power, which I have no idea what that is. So I have 8 times 8 times 8 times 8. Anybody help me out on the calculator? 4,096. A to the third to the fourth becomes a to the 3 times 4 is 12. And b to the fourth is b to 4 times 4 is 16. All over a to the third and b to the negative third. Alright, my 40,096, that's not going to simplify with anything. I have a to the 12th in my numerator, a to the third in my denominator. Okay, so now these are going to simplify. Where do I have more? More in my numerator. How many more? 9 more. I have b to the 16th, and I have a b to the negative third in my denominator. This b to the negative third is really a b to the third in my numerator, and that gives me b to the 19th. Anything else to simplify? Nothing. Put a box around it, all done. It's a little different. We're going to be rewriting expressions, so rewrite the expression as a power. So 8 to the third, 8 times a to the third, b to the third. Notice that a to the third and b to the third, right? So a to the third, b to the third came from a to the first, b to the first with a 3 on the outside, right? And then I could go back, distribute, and I get a to the third, b to the third. So that's how I get from here to here. Question becomes is I have this 8 here. So do you guys notice anything with an 8 and a third power? Yep.
It's 2 to the third.
Yeah, 8 can also be written as 2 to the third. So I have 2 to the third, 8 to the third, b to the third, which really means that I have 2 ab all to the third power. So that is rewriting 8a cubed b cubed to as a product as 2ab all to the third power. Alright, and we can do the same thing with 60. So r squared, s squared, and 16. Can I rewrite 16 as a square? Yep. So 16 is 4 squared, r squared, s squared, s squared. And then I'm just going to rewrite this as 4 rs all to the second power. This will come in handy when we get to the section where we're solving these kind of equations, solving exponential equations.